Come on. You can do it. All right. So let's start with the screen. So we're down to almost the end. Today is the 23rd. We have the end of this week, Friday, we're going to have our last regular lab, and we'll have a surprise quiz. So be surprised. Yeah. And then we have one more week of class. So I'm thinking I can squeeze a quiz in on the 30th. That sounds fun, right? So we get two more in. That would give us something to work with. All right. I wanted to give you one today, but my life just didn't work out. So this week we have the last regular lab, and the week after that you have your final project to do. And then it's, time for studying hard, and no more gaming, no more partying. All right. Any questions on any of that? Okay. So I want to just touch on binary trees a little bit, just because, you guys have had a chance to ponder on them for a little bit now, and I'm hoping that you have some questions before we move on to something new and different. But the essence of a binary tree, right, of this kind of problem is that whenever we have something, right, it's recursive. Whenever we want to do anything, it's recursive. So if we want to find something, we start at the root. If it's less than the root, we go left. If it's less, we go left. We keep looking at each node individually, because each node is the head of its own tree, if you want to think about it that way, right? And so if we want to add or if we want to get or put or anything onto a tree, we want to find the height, or if we want to find the node count or anything like that, it's always recursion, right? Does somebody have a question about binary trees? Do you have one, Logan? No, you're good. Everybody here is good on binary trees. Every aspect, you're good with that red-black removal thing and all that. All right. You don't have any questions? You don't have any questions. So let's look at generics. Now, generics have sort of two levels to them. And the base level, it's all very simple, right? You can do certain simple things with it, and it just makes your life better. But then there is the deeply weird stuff that will hurt your head if you ever have to think about it, and you almost never will, right? The only time normally you care about this stuff is if you're designing some kind of container class, and most of the time in your programming careers, you won't be doing that. I mean, I have you do that because it's an important part of your basic understanding. But once you understand how the containers work, then for most of the rest of your life, you just use them. All right. So the basic idea is that we add variables for arbitrary types to classes and static methods. Excuse me. So we have these generic types that we use. They have a variable that stands for a type. And the compiler can identify these types and use them to check correctness at compile time. Typically, we use single capital letters for this, and I have a typo in my EG, I see. E.G instead of E.G. Anyway, so we have T, K, and V are sort of the names we use for these kinds of variables. I mean, you don't have to, it's just what people usually do. And generics work by erasure. So these generic types are only known when you're compiling the program, not when you're running it. And I know that this is a difficult concept in some ways for you if you're using an IDE, right? Because you don't see a separate compilation step and a separate run step, but you have to know that it's there, right? Because first your .java files get translated into .class files, and then those .class files get run. And it's that translation step where the generics are known. And after that translation step, the compiler erases them. It forgets they exist. So that means you can't do, for example, if X instance of T, because T is only known at compile time. And the compiler has to be able to check at compile time. And you can't instantiate an array of type T, because again, it doesn't know what type that is. And you know, it has to instantiate that at runtime, and it just can't do it. And you can't access the class of something by saying t.class, right? Because it doesn't know what the class is. That's only known at compile time. So it can't do any of those kinds of things, which is, you know, most of the time you may not notice that limitation, but sometimes you will. Okay, and so now with this basic bit of information, we can relearn everything we've learned through the whole semester and try to do it with generics. So first we have my min generic list. Remember we had a min list? And so how this looks is now we have min generic list V extends iterable V, where V is one of these type parameters I told you about. It's a variable that just stands for a type. It could be integer, it could be string, it could be something you made up. And when I add something, it's going to return a void, but it's going to take as an argument a type of V. So it has to have the V up here to make use of it throughout the rest of the code. But once it has the V up here, it can use it everywhere. So I have my int size method, that doesn't change, but my get method changes. I'm now returning a variable of type V, excuse me. And my set method changes also, because my first argument is still an int index, but my second argument is now a generic type. And so when I write my min generic list interface, it looks like this. Questions? Yes.
So V isn't a specific type?
It's not a specific type. It's like, you know, you have an integer, and an integer can hold 0, 1, 2, or 3. V can hold int, integer, string, integer, string, array of string. It can hold list. It can hold anything that's a type. Yes, Scott.
Do you have to set, like, capital V is this?
No. So if you recall what happens, the way this gets used, right? When you're writing your list code, you write list angle bracket integer. When you put that integer in the angle bracket, that's telling the list class to fill in that generic type with integer. Okay, that's what the angle bracket does. Generic node. So I'm gonna make my generic list of generic nodes, and my generic node has a data element of type V, and then it has a generic node of type V next pointer, right? So this angle bracket V thing has to get propagated through, so it knows the type, the way to reason about the types. And then I have a constructor for generic node V. Now on the constructor name, I don't have to repeat the angle bracket, right? Because it's the constructor, it's going to just copy whatever is at the declaration of the class. So I can say constructor of generic node takes a type V, and I say this dot V equal V. And then I can also take a constructor with a generic V and a generic node V node. So this V needs to be here, right? So this is the way I would write the generic node for my min generic list. You with me? Is anybody with me? Okay. Yeah, I ask if you're with me, and nobody reacts in any way. So, all right. So now let's take a look at our linked list class. And our linked list class is going to start with generic linked list V, and it's going to implement min generic list V, right? And then I'm going to have a generic node V of head and tail. Now I have my add V method. And all this code kind of looks the same as before, except I've got these angle brackets. Now, if I'm doing a new generic node, it's on the right-hand side of the equation. I can put empty angle brackets, and the compiler will infer the contents of the angle brackets to be the same as the things on the left-hand side. So I can leave them off there, but I could also put a V in there if I wanted to. And then in this case, when I'm doing my add, I'm going to say if the head is null, then I'm going to instantiate both the head and the tail. Otherwise, I'm going to say the tail.next is equal to the new thing and then update the tail. So this is the same linked list code that we had before. It's just generic now. Bless you. Okay, the size method doesn't change at all. Nothing in here is even slightly different. But my get method is different because the return type is now V. It could be anything that I'm returning from this, but that's the way it's going to look. So when this is going to work the same way as before, I'm going to start with an X that I initialize from head. As long as X isn't null, I'm going to go to the next one. And then I'm going to say n minus minus equals 0 and return x dot v. So when I find the nth thing, I will return the value from it. And the compiler can check that x is of generic node angle bracket v, and the angle bracket v is going to match this return type. So it can check that, even though it doesn't know what those things are, it can check that they're the same because they're both the same capital V, right? So that's how that works. In the set method, we have the same thing, right? We have the set takes the generic type, and everywhere where I used to put like integer, right? I just put the capital V now, and now it works for everything. And my iterator class, so I have an iterator V as my return from iterator because this is implementing iterable. And when I do the new iterator, I can put empty angle brackets because this is this is when I'm doing a new, it can infer that. But I have to, when I put my my little variable in here, I have to instantiate, I have to give it a type, right? I don't on the right-hand side, but I do on the left-hand side. And now, and so the way this worked, if you recall, I took a generic node, I instantiated with a null data value because it doesn't really need one, right? And null can match any type. And then I'm going to have, as my next pointer, I'm going to have the head. And then the way this works is I say has next, I return x dot next equal null. So if I have an empty list, this will work, right? You with me? You remember how this goes? Okay, and then on my next method, right, first I update x equal x dot next, and then I return x dot v. And that's the way that worked. And now when I go to write my main method, I have a test. I have my generic list test class, and I call this list on here. And this is a generic linked list with a type of integer. And this test class is here. And let's take a look at the test class, generic list test. So generic list test is going to take a min generic list of type integer. It's going to say final int n equal 10. And then it's going to say for I equals 0, I less than n, it's going to add something. And then it's going to initialize a count method. And it's going to say that if the list.size isn't equal to n, we're going to throw an error, right? We're checking things. And then we're going to go through the list and we're going to print everything and count everything. And then we're going to assert that we're going to check that the count is correct. And then we're going to say that list.get3 equals 3, because that's what we put in. We put in each index the value that's the same. And then we're going to set element 3 to 20 or 28, I guess it is. And then we're going to check that list.get3 is 28. And if it's not, we're going to throw an error. So this is just a very cursory basic test that my linked list works, right? So let's run that. What do you say? Huh. Huh. I got the name wrong. Oh, generic node, not min generic node. And generic list test. Cannot find symbol. Oh. I always have to relearn this lesson. No, that's not it. How about that? I have bugs. I must have renamed the class and failed to notice. Oh, I'm sorry about this. I thought I had perfect code. Where's my generic list? Okay. What? I have a missing class. How about that? Okay, well, let's write ourselves a class. Let me take one quick look to see if I've got it somewhere. Doesn't look particularly like it, does it? Okay, so I have a missing class, and that's one of the reasons why this isn't working. And Okay. Um, okay, so it says I don't have an add. I have a min generic list. Let's take a look at my min generic list. I have an add. Why is it complaining? Okay, it just wasn't compiling it. I thought it would find it for me, but it didn't. Okay, so now I can say Java minus, well, Java generic list, generic linked list. There we go. Nothing easier than that, right? Okay. So let's take a look at that again. So in my generic list test, right, I have, well, this doesn't need to be here. That's silly. Okay. I have my, I'm surprised that's not a compile time error, actually. Huh. All right. So anyway, and what I have in here is I have my test method, and this is taking a min generic list integer, right? And then if I go through here, I don't have the generic type has been reified. It becomes an integer, right? And so I can do all the normal things I would do on a list of integer, but I could also make a test that worked on a list of string if I wanted to, right? So I could take this same test and I could say 12 comma, well, 12 comma 34, right? I could copy this and I could put, instead of integer, I could put string, and then I could put I equal plus, right? And then I could, down here, I could say list.get 3 equals, and instead of 3, I could say I equal 3. And then down here, I could say list.set, and I could put a 28, and I could put a 28. And in principle, that should still work. And if I go to my linked generic linked list class, and I go down to the bottom, could I have a little less talking, please? We'll call this list 2. We'll put a string as a type. And then we'll put a test 2. Actually, let me see if I need to do that. I think I do, but let me just check. Yeah, okay. I need to give it a different name. Oh, maybe I don't need to give it a different name. Let me put this back. Yeah, it's not going to be happy with that. I thought maybe it got smart. Sometimes I test things on Java, even though I've used them in a certain way for years because they improve them. But all right. And now I can run my code and I get the string version. Now here's kind of a cool thing, or a non-cool thing actually, is because things are in Java, because the types are erased, right? That means it sort of forgets what's in the angle brackets. And if it doesn't really know how to distinguish test of min generic list integer from test of min generic list string, it only knows the difference between those things in the angle brackets at compile time. So it won't let me overload based on a type in an angle bracket, which is a limitation. Okay. Yes, Drew. So if I take a method called test and it takes something called an argument of type string, and I have another method with the same name and it takes an argument of type int, I can put both those methods there and the compiler will just call the right one. All right. Are we good? Okay. And I have to update this because clearly I left something off. All right. And so that's how we did the generic linked list, but we also have a generic array list, right? And the generic array list also implements min generic list, but this harks back to the beginning of our course. But now we have a sort of an interesting problem, right? Remember I told you we couldn't create an array of type new T? So what we have to do to make this work is the array that we keep inside, the one that we grow and what all, has to be of type object, because I don't know T. Excuse me. And so I'm stuck with that. And but that's okay, right? I mean, everything else kind of follows through. I have my grow that uses object because the base type is object, and so that's fine. Man. But this is where we get to something awful, right? I want to return an element of type V from position N. And I can put a cast of V on data N like this, but the Java runtime can't actually make that check because it doesn't know what V is at runtime. And so what it does, it could give me an error, I suppose, but what it does, fortunately, is it gives me a warning. And there's nothing I can do about that warning. If I want to write an array list class, a generic array list class, there's no way to write it such that I don't get a compiler warning. This is, I think, a design flaw, but nobody asked me. And so what I can do is I can put this annotation on here that says suppress warnings unchecked, and then I won't see the warning. You're right, isn't that a great solution? But that's what happens when you do erasure. Now, normally what I would do if I wanted to cast something like this and I wasn't sure about it, I would put it if instance of V, but I can't do instance of V because it doesn't know V. So it will give me an error for that. So I'm just stuck with putting a cast here and putting a suppress warning. And it just has to trust me that I know what I'm doing. But that's the only place where I have to do something awful. And the rest of the time, everything can just sort of work out, right? So, well, no, I guess there's another place down here. So when I do my iterator, I get stuck with that same problem because it's essentially doing a get. But the nice thing is this code here, right, looks the same as the code we just saw. The thing that changes is I have the word array here instead of linked, and that's it. And the same test runs, right? And if I want to download this class, I can type. And let's add generic array to that monstrosity. And then I want to say minus CP, I can say array. And I get my same integer test runs, right? And if I want to copy the two lines for calling the string test, that will also run. So what's nice about generics and about the overloading and about the interface system, right, is it gives you a way to make things more modular. It gives you pieces that you can swap in and out without the rest of the code noticing. Cool, right? All right, any question? Yes, Vanik.
Yes.
Yeah.
Could you play erasure one more time?
So erasure means that the things inside the angle brackets are only known at compile time. And compile time is that phase of your project where you translate from .java to .class files, right? And you normally don't really see that as a separate step in an IDE, but when I'm doing it on the command line, you do, right? So it's one of the things you lose when you go to the IDE. Yes, it makes a lot of things simpler for you, but you miss what the distinction is between compile time and runtime to an extent. All right. In general, though, if you want to distinguish a compile time and a runtime error, it's pretty easy because a runtime error in Java is going to have a stack trace. And if there's a stack trace, it's a runtime error. And if it doesn't have a stack trace, it's not. So syntax errors are going to be compile time, right? All right. And let's take a look at what else we have. Okay, min generic map. Now we did the list, right? We did our two flavors of list. Now we do the map. Should be just the same thing again, right? Let's take a look at it. Okay, so we have a min generic map. And the min generic map has K extends K comma V. So it has two things on it this time. So I have a key and a value. And I use K for key and V for value, right? But everything else is the same. I've got the K comma V up here. I've got a put, I've got a get, I've got a size, all right? I have my generic map entry. So my map entries are kind of the same thing. I have a final key, but I have a KV on that as well. And I have a KV on the constructor. And again, the angle brackets with the type names don't get repeated on a constructor. And then I have my generic array map, right? And then I have my entries, my list of generic map entries, which I just used a standard array list. And then I have a put and a get, right? So this is you remember the array map. That was our simplest one. Yes.
Why is the key an object?
A capital integer is an object. And so everything just kind of flows through the same way. I have my iterator. So my iterator here is a generic map entry KV. So it's got double angle brackets in it when I go for my entries.iterator. Right? So those things can nest. And then I have a generic map test, which is going to work kind of like generic array test. In this case, it's being told we have a string and an integer, and it's gonna, the types are gonna be realized as that. So let's take a look at, okay, and now let's take a look at the generic hash map. So the generic hash map is going to also look very similar, right? I'm going to have my hash to index has got to be there. And this is just going to work kind of generically because the method hash code is on java.line.object. And that means every object in Java has that. And so we don't have to worry about whether K has a hash code on it. It's guaranteed to do so. And this code all looks the same apart from the type annotation. So let's just see where they occur, right? So we have the KV here, and that gets the min generic map here, which has to replicate the same two in the same order. And then we have a list of generic array maps. Oh, so the way I did the buckets in this thing is I put each bucket is a generic array map. So I reused the generic array map inside the generic hash map. Now that's something I could have done before. It's a little simplification, but you'll see how it works. So what I can do now, right, is I can initialize my buckets with generic array map. And now this hash to index, you've seen this before, right? I take the absolute value of the thing, and then I take a modulus with buckets.size. Now my put method is much simpler because I used a generic array map as my bucket. So what I can do with this setup is I can first find the index, I can get my bucket, and then I can put in the bucket. I don't have to have that loop there because I have it inside the bucket class itself. You with me? True. So if I go back to my generic array map, when I do a put, I have to loop over the entries, right? And I have to look for where the keys are equal, right? I don't need to have that in my hash map because I'm using my generic array map as a bucket. Now, before when I did this, right, I did a list of the bucket item of entry. But here I simplified it by saying that I have my generic array map as my bucket. Yeah, I'm just reusing that logic, which I didn't do before, but I could have done, right? And whenever you can reuse logic, generally, it's a good idea. If you want to code something twice, chances are one of those times you'll do it differently and there'll be a different behavior, and one of those behaviors will be something you don't expect. Any questions? All right. So my get method is the same. I get my index, I get my bucket, I do a get on the bucket. For my size, I take a sum, I go through each bucket, I add up each bucket's size. The iterator, well, we walked through these iterators before. It has sort of a complex structure to get the iterators over the entries. And, but you know, it's, you remember there's a while loop in here that we had to work through. Okay. And then I can apply my same generic map test that I used on the array map. I can use it on the hash map. And I could use it with string or integer or any kind of test I want to devise. I could interchange all those things. Are we good? Are we ready for something different? All right. Generic tree node. So now let's take it. We did binary trees, right? We have binary trees fresh in our mind. We have generics fresh in our mind. Let's look at the generic tree node. So the generic tree node, unsurprisingly, we have a K and a V, a K and a V. I made it extended generic map entry. I'm not sure why I did that offhand. But anyway, I have a generic tree node left and right, and I have my generic tree node with the key and the value. So I guess I just did it to get the key and the value. So then I have my generic tree map, and now something weird happens. look what happens. Public class generic tree map, angle bracket, K extends comparable K, comma, V. Now, why is that there and what does that mean? The concept here, right, is we remember with a generic tree, with a tree, we need to have a comparison, right? We can't just make do with equals and hash code. We need a method that isn't on java.lang.object. And so if I just put a generic K or V, right? If I put a generic K there, the Java compiler is going to say K might not have a compare to method. It's a possibility, right? And so I have to tell it that, yes, I want a generic K, but I want a K that has a compare to method. And I want it to be a method that allows me to compare with K itself. And so the way to write that is by putting this extends thing inside the generic type parameter. So I'm going to say that type K extends comparable K. And if I have it here, right, then it will keep that in its mind and it will check it everywhere I use it. So when I say implements min generic map K comma V, it's going to understand that K is this K and this K extends comparable K. So this is the basic trick that you need to use if you want to have something that has a particular method on it with your generics, in this case, compare to. All right. And now everything can sort of go through with that one bit of strangeness. Everything can sort of go through. We can have a put, a get, a size. None of this is going to change. I guess I wrote the iterator method a little differently here. So I think what I did with this iterator method is I tried to make it iterate through things in order. So I have an add all method on here somewhere. And I need to find that to see how the rest of this logic works. But then I have my put method, and it's going to have a generic tree node as a put. I put two private methods on here that do this. I have my main that's going to call my test functions. I have my add all, which is going to take a stack of generic tree nodes and a generic tree node. And it's going to say, you know, while x does not equal null, stack.add x, and then x equal x dot left. So it's just going to add everything down the left side. And then I have my size method. So this is going to add everything down the left side, this add all. And let's go back up to where I use it. So I'm going to call this add all, and I'm going to fill in this stack here, starting from the head. And then with my iterator, I'm going to say has next is going to be if stack.size is greater than 0. And then when I do my next method, I'm going to say stack.pop. And then I'm going to say if node.write does not equal null, then add all stack node.write. And then return node.k. So if I do my iterator in that way, right, I will sort of hang on to the minimum number of things in my stack that I need to, but I will iterate from the beginning to the end. You follow all that? All right, so let's see if we can run some of it. Who knows if it'll work? That looks fine. Generic map entry. Generic array map. Generic hash map. Generic tree node. Well, let's get map. Tree node. And There should be a test class, right? Generic map test, yeah, all right. Another thing I left off, it looks like. Uh, Yay, it all compiled. Look at that. Who'd have thunk it? Look at that. Okay, so here's my generic map test that I made, right? So I'm going to say, I'm going to put like key, I have a string integer map, and I'm going to put key value pairs in. And then I'm going to say for n equals 0, and I'm going to go through the map, and I'm going to count up, using the iterator, I'm going to count things up, and I'm going to make sure that the size is the same. So it's really a very, very basic test. It doesn't test much of the functionality at all, but at least it tests it a little bit. And one of the things, right. So it checks that the same number of things I iterate is the same number of things in the size. Okay. All right. And I think that will do it for today's lecture, unless there's any final questions. You all mastered all that? All right, be prepared for the surprise quiz next class.